Here we have a problem on integration. That is, we have to evaluate this indefinite integral. Okay, now let me start working on this integral 1 over. In my first step, let me write this 16 as 4 square. So 4 square positive x negative 5 the whole square dx. Now let's consider a formula in integration, that is integral 1 over a square positive x square dx is equal to 1 over a r tan, let me write the stuff over here, r tan x over a positive c. Whenever I integrate stuff in the form 1 over a square positive x square, its integration is 1 over a times r tan x over a positive c. Okay, to get the given integrand in this form, I just write this 16 as a 4 square over here. Okay, now let's compare the integrand over here, the integrand over here. At the place of a square, we have 4 square, but at the place of x square, we have x negative 5 the whole square. Actually, a single variable has to be squared, but instead of a single variable squared, here an expression has been squared. So only if a single variable is squared over here, I'll be able to use the formula we have discussed over here. So what do we have to do for that? We have to replace this x negative 5, replace this expression by a single variable. For that, we have to do u substitution. That is, I'm going to substitute a new variable u for this expression x negative 5. Let me do it. So let u equals to x negative 5. Okay, since I have substituted a new variable u for this expression x negative 5, I have to get this complete integration in terms of the new variable u. Okay, when I get the complete integration in terms of the new variable u, instead of dx, I must have du, so that I'll be able to do integration with respect to u. If I want to get du at the place of dx, what should I do? I have to get derivative of this u. If I get derivative of this u, I'll be getting du. Since we have the original integration with respect to the variable x, now I'm going to find derivative on both sides of this equation with respect to x. When I find derivative of this u with respect to x, I'm getting du over dx. When I find derivative of this x with respect to x, I'm just getting 1. So the derivative of the constant negative 5 will become 0. Okay, now to solve for du in this equation, I have to get up the denominator dx over here. For that, I multiply both sides by dx. When I do so, this dx will cancel out. I'm getting du equals to 1 times dx is dx. Okay, now let me continue with this integration. Integral 1 over 4 square, and for this x negative 5, we can substitute the new variable u, then we get 4 square positive u square, and for this dx, we can substitute du. Okay, let me I've done it, sorry. Okay, now we got this integrand exactly in this form, 1 over a square positive x square. At the place of a, we have 4. At the place of x, we have u. That is single variable. U is squared over here. Now I can use the formula we have discussed over here. So the integrand, the integration of this function is 1 over a, but at the place of a, we have 4. We have to write 1 over 4 times arc tangent x over a, but at the place of x, we have u. At the place of a, we have 4 positive. The constant of integration c. Actually, it is an indefinite integral. Whenever I evaluate indefinite integral, I must add the constant of integration, and the question says use c for constant of integration. So once I integrated this function, I'd added this c as a constant of integration over here. Okay, now let me continue the next step. 1 over 4 times arc tangent. Okay, u is a variable taken by us. It has to be replaced by the original stuff, that is x negative 5. So we can plug in that x negative 5 for this u. Then I'm getting x negative 5 over 4 positive c. So this is the result of the given indefinite integral.